Hello, students, and welcome to our math lesson today. It is April 6th, and we're going to start with a do now chart about emotion management strategies. We've done a lot with that this year. Our objective, of course, will be something new. We're going to begin working with polynomials. And our essential question is, how can I add and subtract polynomials? Mostly adding today. Our assignment, let's roll this down a little bit. We're going to complete the do now, complete the work page. We're going to complete the exit ticket, and then make sure you show your work to me. That's the most important thing. If you don't finish, you can do that for homework. And important, I want you to remember, we are now in the fourth quarter, okay? So we're working with those pre-algebra concepts, getting you ready for high school. So I want you to stay focused because I know you've got this. I'm super excited for you to go to high school, and I know the teachers will enjoy you as much as I have. So we'll get back to our exit ticket in a minute. But first, our do now is about emotion management strategies. And we're focused on school here, and it says describe a school situation that could cause strong emotions. Could be when you get a test back, or you run into a person you don't get along with, and you misunderstand something they say, you have a disagreement. So when you think about that situation, I want you to describe a negative decision that might be made as a result. Like maybe if you get a bad test grade, you might yell at the teacher or storm out of the room or something. Now, after you've described that, so the first box, you're going to describe the school situation. Then, and it doesn't have to be real, you can kind of make it up, or, you might have a real situation you want to work through in your head, and that's awesome. So in the second box, you describe the negative decision. And then in the third box, I want you to rethink that and offer an appropriate management strategy that might be had for that decision. So take a few minutes and work on the chart. So I apologize. When I sent this paper through the printer, the scanner, it just really, I don't know how it did this, but it went crooked. So we have Crooked Math Day. So I'm just going to write that up here. Crooked Math Day. How about Crooked Polynomial Day? Our unofficial holiday, but we love it just the same. So now let's think about these polynomials. We have this prefix poly that means many. And what is it? It's an algebraic expression that consists of numbers and variables, or a combination of numbers and variables. Numbers and variables. So we could have, 2x. We could have x squared plus 2x plus 5. Okay, all of those are polynomials. Now, when we write them in standard form, and the terms should be written so that the exponents go in reverse order from left to right. Also, and I want you to write this here, we write them in ABC order. And with the constant and number that's by itself last. Okay, so let's write each polynomial in standard form. So I said that the constant will go last. 7 is the constant. So I would write this negative 2x. Now, we have an invisible positive sign in front of the 7. So negative 2x plus 7. Number 2, we do the exponents in reverse order, so we have to put the n squared first. When we have a positive variable or a number first, we don't have to put the positive sign. That can become an invisible positive sign. But we do have minus 8n. and then plus 14. And that's the correct way to write that polynomial. Number 3, we'll start with the exponential term, the 10a squared, then the minus 2a, and then the 25 has an invisible positive sign, and we'll put that last. Number 4, we have all w's, so we're going to start with the highest exponent, so that's that positive 7w. So 7w to the 4th, then we have a positive 8w to the 2nd. So it's not the order of the numbers, it's the order of the exponents. So it would be 8w to the 2nd minus 2w. And there's no constant on that problem. So let's try 5 and 6 yourself, and let's see how you do. Okay, let's see what you did. We have p minus 2p squared plus 1 minus 4p to the 3rd. So we're going to start with this minus 4p to the 3rd, and then minus 2p squared. And then the p has an invisible positive sign, plus p plus the constant at the end of 1, and that's it. And then in number 6, I hope you got number 5 right. Let's see how you did with number 6. We start with the negative y to the 3rd power, and then we'll put the positive 4y squared, and then the negative 10y, and we have an invisible exponent of 1 there. Let me write this y squared so it's a little clearer to read. Okay, minus 10y, and then our constant, minus 27. Let's go on. Now we're going to add polynomials. We're just going to do a few of them today, and we'll be doing more adding and subtracting of polynomials tomorrow. So polynomials can be added by simply combining like terms. We've talked about like terms. They really have to be very much alike. Okay, you can't force them to be alike. Now, when we combine like terms by, add these polynomials and combine like terms, we want to make sure that the final answers are written in standard form. So here we have the quantity of 7x plus 15, and we're adding the quantity of 4x minus 9. So 7x plus 4x is 11x, and then 15 minus 9, so it's 15 plus a negative 9, which is the same as 15 minus 9, which is positive 6. And that's our final answer. So number 8, we have the quantity of negative 3a plus 16 added to the quantity of 2a minus 27. So we'll start with these a terms. Negative 3a plus 2a. So that's negative 3 plus 2, which equals negative 1. So we don't write negative 1a. We write negative a, and the 1 is implied. So that takes care of the a terms. Now we have 16 minus 27. So that would be negative 11. And that's our final answer. Number 9, we have the quantity of negative 4 minus 2k added to 7k plus 23. So we're going to start with the k terms, okay? We're writing these in correct standard form as we've been asked to do here. So we have negative 2k plus 7k. So negative 2 plus 7 is 5k. And then we have negative 4 plus 23, so that's a positive 19. And that's written in standard form. Number 10, we have the quantity of negative 15m minus 37, to which we add the quantity of negative 1 plus 8m. So we'll start with the m terms. We have negative 15 plus 8, so that would be negative 7m. So we're done with the m terms, and then we have negative 37 plus -1, which is -38, is our constant. So go ahead and try number 11, 12, 13, and 14 on your own and come back and let's see how you did. Okay, so I hope that you worked hard on your own, and let's try to get these done. We have the quantity of 7c squared plus 2c. To that, we will add the quantity of 6c squared minus 8c. Well, they both have c, but the first terms have c squared, so we'll start there so that our answer is in standard form. So 7 plus 6 is 13, and the quantity is c squared. We're just combining like terms. We don't do anything with the exponents when we add and subtract. And then we have, for our c terms, we have 2, positive 2 minus 8, which is negative 6c. We didn't change the c's. We only combined like terms. Number 12, we have the quantity of 3x minus 8x squared, to which we add the quantity of 2x squared minus 3x. So we'll start with the squared terms, negative 8 plus 2. So negative 8 plus 2 is negative 6, and that's our x squared term. And then we have 3x plus minus 3x. Well, 3 minus 3 equals 0, so 3x minus 3x cancels itself out, and our final answer is negative 6x squared. Number 13, we have trinomials. We have that word tri in there. We have 3 terms in each one being added together. So we have 8 minus 5x plus 6x squared, and to that we add the quantity of 5x squared minus 8x minus 7. So we'll start with the squared x squared terms. Positive 6 plus 5 is 11x squared. Negative 5 minus 8 is negative 13x, and 8 minus 7 is a positive 1. And that's our final answer, incorrect standard form. And then finally, number 14, we have the quantity of 5r squared plus 7r minus 6, to which we add 8r plus 3r squared minus 1. We'll start with the r squared terms. So 5 plus 8 is 13r squared. And then the r terms, oops, I made a mistake. I added, see what you could do. You got to be careful with these polynomials. Okay, I added an r squared and an r term, and you can't do that. That's not combining like terms. 5r squared plus 3r squared, that's 8r squared. And then 7 plus 8, 7 and 8 are 15, so that's 15r, and that's an invisible 1 there, r to the first power. Then we have negative 6 minus 1, which is minus 7 or negative 7. And that's our final answer there. So let's go back to the exit ticket. To add polynomials, we must combine like terms. Right? Did you remember that? Now, I also have some extra, if you finish early, I have a fun little activity, Jackson Pollock inspired art. And I have an April weather word search for you. So let's see if we can find rain showers. Rain showers, rain showers. I don't see it. It's a long one. Let's see if we can find one of them. Let's see. Oh, I found one. I didn't find rain showers, but I did find drizzle. So there's your first word, drizzle. So go ahead and finish up. Thank you for working so hard. Make sure to carry an umbrella and wear boots when it rains outside. Thank you for being part of our Wonderful math class, for working so hard. And remember, keep practicing all of this because as you do, you'll be great.